Today we will have some art, as you see right here. Let me show what I drew. Then we will move to some mathematics. As I promised, we will do one practical example, as you can see from the title already. And then finally the story will come, and after the story some animals additionally, as usually. And I would like to say that it's really funny because most of the people, I think, they don't like mathematics really much, but now it seems they're listening even during the holidays. So it's really good. I'm proud of all the students, and some of you will understand very good, maybe even better than me, and you will become experts. So, but I hope you will say one day, this guy, he gave me the motivation and showed me that I can understand as well. So I hope I'm a good teacher, and let's see how it will go today. Sometimes in history we used first charcoals and then pencils. So I don't know who chose the size, how they came to this size, but I think they're all pretty much the same size, but some are thicker. So I think if you are a real professor, you need to have thicker, something like this. But we won't spend time here. Let's see, log of x and linear ODE, which means ordinary differential equations. Besides ordinary, we have also partial differential equations. And differential equations are the bedrock or fundamentals of all the physics and also mathematics. And they can present various things. Usually they represent some process which is evolving through time, or even stationary processes, and you have then different parameters. You can ask AI and they will tell you what equations are. And first we have equation ordinary of, say, nth order, and it looks like this, the Tn. We chose y here and t as a parameter, but we could also use x here as a parameter. It doesn't matter. And plus dot is always dy dt a1 plus a0 y is some function f of t time. And any equation of the nth order, the order is n, can be actually transformed into system of linear ordinary differential equations. And you can also again ask AI how to do that. I will just write down, this is d, now y is a vector, dt is actually the same as some matrix A, which can in fact depend on t, times y, depends on t, here also on t, plus some b of t again. And this is a matrix, these are vectors, as we have learned before. And if this matrix and these coefficients actually can be non-linear, it can be sine t or t squared or whatever you choose, but the equations are still linear because the terms which we derive are linear in nature. Excuse me. So, if A is not function of t, is not a of t, then we say the system is autonomous. And if b of t is 0, which we will say b is 0 vector, then the system is homogeneous. What is noise? Some glitch. So, how to solve this? We have different approaches to solve, and we will look just actually at the simple with only two parameters model. So we will say that y is actually y1 and y2, and a, we will say that are some constants a, b, c, and d. And d is 0. So for simplicity, And if these are not constants, then you usually need to use numerical methods to solve a question, and a really simple Runge-Kutta method, for example, it solves. And if this is the case, we can solve simply with eigenvalues, and we search for determinant of A plus some parameter lambda and I, which is identity matrix, and this in fact is lambda squared plus D plus A minus D plus A, I think, plus AD minus BC is 0. And from here you get lambda 1 and 2, and you get the eigenvectors y1, y2. We could also use x1 and x2. And solution, in general, we call it complementary solution, is actually some constant c1 times eigenvector 1 times exponent to the minus lambda 1 t plus c2, some other constant, y2 and a exponent minus lambda 2t. Sorry, it's not so beautifully written because it's harder when you go down. And this solution in the constants we get from initial conditions. And now we will look at an example of law of affairs. And we will say that y1 is actually log of Romeo and y2 is log of Juliet. And if y's are positive, then it's love. If they're negative, then it's head. And one of the solutions, actually complex solution, which we also looked at before, e to the I and something, is a complex solution, and you get sine and cosine. And how this looks, one of the solutions is here, Romeo and Juliet, they met, and Romeo falls instantly in love. He becomes lovesick, pathetic, and he writes to her and tells her songs or whatever. And so his love goes up to some point. But Juliet is not happy. The more he's lovesick, the more she actually hates him and goes down. And then Romeo, and here are y1 and y2. This is y1 and this is y2. And then through time, Romeo began to lose the interest and his love goes down almost to 0. And actually also Juliet's hate goes down to 0. And now Juliet loves Romeo, and Romeo hates Juliet because she didn't do what he wanted. So in this pattern repeats, they go down and up through hate and love all the time. And we can do a phase diagram. Now here we have y1 and y2, and here this is t, time, how it evolves through time. And this is actually a circle or ellipse, if you will, and they are moving in a circle, we can say. And then the next case, we can have something like Romeo love, and then again down, but it dissipates through 0, and Juliet also. And what is this? This is actually a spiral which evolves inward spiral, it converges. And we can have also the case when things go really messy and Romeo is first in love, but then hate even more and love even more, and Juliet also hates and love more and hates, and things just blow up and love and hate go to infinity, and this is unstable spiral, and it's going outwards. So in this direction, say here. So this is how we can model, but if you choose the matrix A, which we talk about, and choose their parameter that depends on time t, and use some kind of functions, you can get different graphs. And even this solution, you have also other solutions, but those three I thought they're the most interesting. So that's it from the mathematics part. I hope you like it, it's useful, And now we will move to story and other part. So thank you for your attention, ladies and gentlemen, and see you soon probably. In a vibrant village, there lived a smart farmer, Gregor, who had a special passion for kitsch. And not just a little kitsch, but so much that no one has ever seen before. His tractor gleamed with layers of gold leaf paint. The stalls for his cows were adorned in Baroque style with intricate patterns, chandeliers, and of course gold. Almost every piece of equipment bore the mark of Gregor's gilded obsession. But this golden vision came at a hefty price. Gregor's bank account was perpetually barren. He approached the village bank, then the regional bank, and then several more, each time requesting loans to fuel his extravagant decorating habits. Eventually, the rejections piled up like autumn leaves. The last very bank manager had stated,
"Your farm, Mr. Gregor, is becoming less a farm and more a monument to poor financial decisions. We cannot provide further credit."
The reality of his gilded folly began to sink in. The farm, for all its golden luster, was actually impractical, and Gregor spent hours polishing golden surfaces instead of working in the fields. Soon there was a critical lack of food for his animals. The cattle mooed with a mournful hunger, the sheep bleated their discontent, and even the chickens seemed to peck at the gilded feeders with a sense of ironic despair. Gregor, surrounded by his shimmering empire, was in trouble. Then, one crisp autumn morning, something utterly unexpected happened. A sleek black limousine stopped directly in front of Gregor's dazzling farm. Out stepped a woman impeccably dressed with an air of sophisticated intrigue. She introduced herself as Anya Kanya, an art curator for a prestigious avant-garde gallery in Vienna.
Mr. Gregor, we've heard whispers of your unique artistic vision. Our gallery is planning an exhibition dedicated to the reinterpretation of rural aesthetics, pushing the boundaries of traditional art. Your farm is not merely a farm. It's a living, breathing, monumental piece of folk art. The hottest farm anyone has ever seen before. We would like to feature it.
Suddenly, Gregor's golden folly was not a burden but a treasure. His love for kitsch, once an expensive indulgence, had unexpectedly transformed his struggling farm into an unlikely, glittering masterpiece, attracting art enthusiasts from across the world, and more importantly, he was chosen to be the leader of the village. He was known for 7 hours long speeches where he never repeated himself. A crow drinking water from the river and looking for females. She's meditating, and let's see the process. How's it going? She moved. It's like a yoga.